It's your boy Chili here. Welcome back to Genesis ROM hacking. In this video, we are going to figure out the darkness and light spells in the dungeon. Previously, we did it with the tactical, and I showed you that it is weird in the dungeon and different. So let me just re-demonstrate that. We're gonna hit this guy with a light spell. He's blinded, and now he's going for a stroll. He's just gonna, yeah, you know how dogs is and all that. So that's weird. Why? And the other weird thing is that in the tactical, the job index was like DDDC. Now it's 0E. And for darkness, I think it's like 0F as well. So why? Well, some interesting things that we can notice here. So number one is something I didn't call out when I did the original darkness tactical video. But we can see that the card value for the darkness and light spell, they are actually, let me see, what is this one? 15 and 16, which is very close to E and F, off by 1. And if you know from other things that I've hacked onto, in the functions, the value given for the action is often 1 less than the value in other places in the code. So in my enumerations, they're often off by 1 from the value that they're using in these functions for whatever reason. I think it's like a zero-based indexing thing. Sometimes they were treating it as 1-based indexing or whatever. It's just stupid. Anyways, doesn't matter. What matters is that in tactical, it wasn't using these values. It was using different values, DC and DD. So I actually had to add these enumerations into here. They didn't. I originally got the values for these enumerations, by the way, from just a list of. Okay, online there is a guide for hacking save states, and it gives you the values of things you can put in inventory and equip slots, and that is what I use to generate my enumeration here. So these values aren't equipable things, but they are used for light and dark spells in tactical. But in dungeon mode, it uses the actual equipable action card values. Why? I don't know. Who knows why? There's crazy shit all over the place here. But that's one thing. So that's one sort of mystery sort of solved. At least I know where these ENFs are coming from. It's not completely crazy, but I still don't know why it's different in tactical. Now the other thing we notice, we can't see it right now. I gotta cast a spell on this guy again. Where is he? Get back here. Get back here. Honey, it's time for your darkness. Why am I? This isn't unmodded. I'm trying to use my spellbook feature, and it's not a modded version of the game, so that's not gonna work. Okay. I'm gonna hit you with some light. Bam! Eat this. Go for your walk. Yeah, you go for your walk. Now we notice that the status here is the same, which is good. That makes life a little easier. Because the status is the same, that means that the debuffs that this guy is seeing are already implemented. We just gotta change his behavior because wandering around is a weird behavior. And we need a way of controlling, the job duration. That's gonna actually be easy enough. All I have to do is in my hook, I check for these new card values, not just the DC, DD that I was checking before. So that's not too bad, but how am I going to figure out the behavior aspect of it, like the wandering around, and how can I get him to just act normally when he's blinded, just with the debuffs, just like we do in tactical? That's tricky. One of the things I tried to do, I tried to set his job here to the same ones you use in tactical, DC and DD, and see if that makes him behave more normally. And I also tried another thing. Could I just unset it here? Because if I unset the job let me just do it here. Set the counter to 0 in here. If I unset the job, what happens? Does it stop immediately? Can I control the job? And the funny thing is, if you unset it, it just goes back on the next tick. So that told me, all right, interesting. There is something else. There is another layer. When I was doing this in tactical, I first looked at the status flags and I realized that they were ephemeral and there was something controlling them, which was these jobs. Now there's another layer. There's something controlling the jobs. And the Steve that is controlling the jobs is in here. So this is a whole new thing that I've discovered, and I've made huge discoveries into the way the dungeon system works. So for tactical, all the enemies that like character sheets are loaded in just like player character sheets. And in tactical, maybe you have maximum, I don't know, like 8 or 10 enemies in a single combat. And so there's space for 10 of those enemy character sheets, and they're loaded in and they stay. Now in a dungeon, there might be dozens of enemies in the dungeon. There's not enough room to load all those character sheets. So what it does is it only has room for like, I think 2 enemy character sheets. And the rest of the enemies are loaded into this array. So each row of this memory is actually space for 1 enemy or maybe some other thing in a dungeon. Maybe like treasure or a trap or something might also be present in here. I don't know. But enemies are present in here. And what it does, there's a function. Well, let me show you. So there's a function here, dungeon process enemy slots. And it is called from dungeon entry, which if you remember that function, it's called when you enter the dungeon and it just remains in it. It doesn't return until you exit the dungeon. And this just loops over all this memory here. I believe there is space for 128 things in the dungeon. And it loops over every one. And, first it checks, it's going to load byte 0. This 82 points to an entry in the slot. Every entry is 16 bytes. And first byte, it checks to see if it's 0. That means that slot is empty. Most of them are empty in this dungeon. And then it just skips to the next one. But it runs through every slot. And it's going to do some checks. It's going to do some loading. Eventually, most of them will end up here for an enemy acts. And what that is going to do, calls enemy act sets sheet A0, which calls dungeon page in sheet. And what that does is it loads a bunch of data from here into an enemy character sheet. And it also loads data from static memory. So the static things like the max HP of the enemy, they go from static memory. And then the things like the current HP and status jobs get loaded from this array. And that forms the character sheet. Interestingly enough, they don't even fill in the name of the enemy in there when it's loading, when it's paging in enemy from this array. But there you go. So it pages in the enemy, and then it runs all their jobs, and then it runs their logic to see what it's going to do. And then once it's decided what it is going to do, once it's decided, the return value D0 is used to control this switch to decide what action it's taken. And then, for example, the enemies that I've seen, they generally go onto this one, which descriptive names are very important for reverse engineering. And then in here, it does a bunch of other checks to see what the enemy plans on doing. So that's the thing I discovered. I discovered this whole system of like paging enemies in and out of memory, because the processing for things like spells and attacks, that uses the exact same logic as the tactical. So it has to have that information available in the enemy character sheet in order to do that stuff. And the way it does it is it pages it in and out from this much more compressed data structure that holds things. I'm pretty sure so this first byte I think is, or second one, I'm not sure, but in the beginning here you have like an ID. What enemy is this? You can probably have I think there are 255 different options, or maybe 128 different options for enemies. What could it be? And that is stored in here, and then their HP is stored somewhere in here, and their position is going to be stored in here as well. And they have 3 slots for 3 jobs. Status jobs is what I generally call it, because it's usually associated with status that ticks down. But yeah, that's basically all the steps that I went through here. This is like all my notes of I'm trying to figure out, okay, what's doing what. Each one of these lines in here could represent like 30 minutes of me trying shit. So it was a long process to figure out how this works, but I think I have a much better picture of how the dungeon processing works, at least at the very top level. But like I I logged, basically, I didn't log, but I manually stepped through and took note of the call stack and the general, like what order the functions are all called in. I also made a preliminary outline of, okay, so what are these? This @ sign represents one of the bytes in this array of, dungeon enemies. So I made like a preliminary kind of mapping out of what these bytes represent. So this one controls whether it's empty or not. I don't know more than that. Number 1, I think, is the enemy ID. There's some offset applied to it, but this is the ID of the enemy that is used to load in static data from that enemy's static data sheet. 2 and 3 is like controlling some processing. I don't know what the hell that is, but byte number 4 is the HP. Oh, these hex values. Okay, I get. These are where the destination is in the character sheet. So this value is loaded into byte hex 76 of the character sheet. 2027 we know is the offset of HP in a character sheet. This byte is being referenced in this function at this address, but that's mostly all I know about it. Don't know what it's done for. This one seems to persist 1 byte of the character status, so the very low byte is persisted, not controlled by jobs maybe. And then these last 6 bytes hold 3 status jobs. So yeah, basically stepping through all this code in the normal case and the case where the enemy is blinded, trying to see where they diverge. So I notice you call into this in every case. Return value D0 controls what you're going to be doing. If it's non-zero, that means you just skip the turn for this tick. The enemy didn't do anything, was idling. If not, you move D5, and now we are going to use that to switch, which is complicated switch. It loads a value from here, and then it uses that value to branch into here to do a jump. And the one that it goes to in both cases is this one. So whether it's blinded or not, it goes into here to do its turn. And here is where the magic happens. It's loading. So the status flags, they're stashed in a global variable, and then they're referenced from there many times. And the ones in the character sheet get cleared and set and cleared, but this stash is often preserved so it can be used. So it loads this stash, and it's checking, does a mask here, and if any of these bits are set, it enters a wandering mode. So this was originally, the mask contained a 6 here, which was the 2 bits for light and dark blindness. I removed those, and now the enemy behaves as normal. All you have to do is remove those bits. Once you find the place where to insert your lever, it's often very easy to make the change. All the difficulty comes in finding the correct place, and the correct place was right here. So apparently there's another status that causes wandering, and I think there's also a spell that causes confusion, and I believe that's probably what this bit is, but I will have to confirm it later on. I'm assuming this bit represents confusion. There's actually 2 bits here. Yeah, 3 is 2 bits, so there are 2 bits still left that are associated with wandering. But we removed 2 for light and darkness because they don't apply. Alright, and that's all you need. And now he's not going to wander around anymore when he has blindness. And because the status bits for blindness are the same, our melee buffs and debuffs, they're already working. So the last thing is calculation of saving throws and changing the duration of light and darkness to match, what is happening in tactical. Now, an interesting thing about light and darkness in dungeon, and just statuses in general. So previously, if you inflicted, for example, light, it would last for 120 rounds. Yeah, hundreds of character turns before the light and darkness would fade out. It was basically permanent. It was effectively permanent, the spell. Now, if we look, this is unmodded still. If we look at the job ticking down here, A9, it's ticking down way faster. So this, the speed at which these things expire in dungeon is actually much closer to what I would expect. This is unmodded, so you see I don't even have to mess around with the turn round timing in dungeon. It's already working good. all I gotta do is just change the value that is applied to match in tactical. And that's actually super easy because we know that, okay, so in tactical, they use the normal card values. So that's all I had to do is add. So I created a function to check if a action card is light or dark, and it checks the tactical version and the dungeon version, which is the original equipped version. And I also, so before I wasn't taking it into consideration, but now I realized that the action cards coming into these hooks as well are offset by 1. So I do the offsetting here, and then I changed these values to represent that. So these ones are increased by 1, and then I also increase the value coming in D2, and then everything matches up with my enumerations correctly. And then the remainder of the logic is just the same here, and it's also the same in here. So it's actually quite easy to hook the spells and modify their duration and saving throws as long as you know the card value. The trick was figuring out that one spot, those 2 bits I had to flip just to get the behavior to work correctly. But in doing so, I learned a lot about how this system works, and it's going to be useful information going forward. But just for information's sake, the flow goes enemy acts, and that is going to do enemy acts sheet A0, which pages in the sheet from our array. And so that calls clear character sheet. And then this is all just loading data from 2 places. So A0 is pointing to the location in this array here, and it's loading in a bunch of stuff. Here, for example, this is loading in the jobs. A1 points to where the character sheet is, the character data is statically in the ROM. So there's an array here of enemy data, and we can see here, enemy 0 is called Kakantizu, enemy 1 is called Grulap, and then we got Warrior, Uklangor, Lieutenant, Captain, Carrion Crawler. All the enemies can be found in here. And after it pages in the data, into the data sheet, it calls enemy turn start, which calls these 4 things. And these are mostly just doing script processing, checking jobs in a couple of places, in a global place, in the character sheet, in 2 places in the character sheet. And then you return from here, you return from here, return from here, return from here. Here is where the flags get loaded from the character sheet, and then the flags stored in here get mashed together in that, and that goes into this stash, this global status flag stash. And we do some status checks that modify behavior a little bit, and then we return from here, and then we're back in the slot processing function, and we do our switch to determine behavior in the dungeon. All right, let's take a look at the patched version now. See what we get. So we're going into the dungeon. We got our warrior. He's attacking us, and he's doing damage because now I fixed things. Bam! All right, and now I've made him blind, and he is not hitting very often. He's blind. And the blind is gonna run out soon, I think. Yep, it just ran out. So now he's gonna kill me. Maybe. Yeah, he killed me. Cool. Blind you again. Bam! Alright, and now you're gonna be super easy to hit. There's a hit. There's a hit. There's a hit. There you go. So, blindness does not cause them to just wig out and take a stroll. They can still attack, but their chances of hitting you go down drastically, and your chances of hitting them go up. And the duration of the blindness is reduced by a little bit, and is also dependent on your intelligence. It's all working according to plan. And also now the duration of these effects, they more line up between tactical and dungeon. Before tactical, it was basically permanent. And in the dungeon, it went away, fairly quickly. It goes away even faster now, depending on, your luck and your intelligence. But it lines up very nice with tactical and in the dungeon. Now, one thing that you've noticed me starting to do here is incorporating the intelligence into how well you cast spells. because up until this point it's basically a useless attribute. Like strength is so good, intelligence is so useless. I hate it. I think it's stupid. So, and I mean, you can't blame that on the developers because that's the way they do D&D rules work. But I'm gonna exercise my little bit of creative license here, and I'm gonna change that. Starting with darkness here, just add a little bonus to the duration for intelligence, giving you that incentive to maybe, you know, get that stat, choose a character with a better intelligence stat. And I want to continue that with many of the spells. We're going to have to think about how it works with cleric spells because their primary stat is wisdom, but there are some spells that are shared between clerics and magic users, so there's things to work through there. But next video, I'm just going to do a very easy one, very quick one, Magic Missile. We're gonna tweak Magic Missile a little bit, and that should be a fun, quick little video. Until then, thanks for watching. Hope you enjoyed this video. If you did, please click the like button, helps a lot. And I will see you again with some more ROM hacking.